So the commands for us to run in the following stage is block mesh, as I mentioned, and the top set, and a series of other commands. So let's go here. So if, as I said before, we run block mesh, and we will immediately have a warning or error here, because if we look back our block mesh dict, we didn't indicate what kind of dictionary it is and what is the OpenFOAM variants. So this is actually what we missed. So the warning is check the header. So we need to add this header to our files. Then I will change the class to dictionary. So that's all our files currently is about the dictionary setting, so we change it to dictionary. And now I will run block mesh again. Let's see how it goes. Yes, it is good because it gives us the patches and give us the definitions, so everything run correctly. And if I open the preview, and I will let you know how to do the preview quickly. Here, because I have run something, I can directly define a blank file, and I save it as, in the demo folder, I save it as demo.foam. Again, I don't need to apply any extension, I just save it. So the purpose doing this is we use this file as our access to all the OpenFOAM files. So I will go to that folder by copying the path here, and it would find the demo foam here. And then I just apply it in the preview, and it will give me the mesh currently. And also the patches, we will see a lot of patches here from block mesh. And if we see the surface with meshes, I would say it's a very regular or very sized cells for each. And also I only have a unit cell along the thickness direction. That seems good. And the next stage, as indicated in this slide, is run the top set. We will imagine, before running it, we imagine that because we didn't add any head file, it may give me another warning or error messages. Yeah, exactly. So it didn't say any and didn't see any successful running, but it indicates I should check the head file in this form. So again, I just copy this, and I will go to my top set dictionary. In the very beginning, I'll just paste this here. So if you run other OpenFOAM variants, the head file may be different. By this warning, you can directly copy the head here to use the corresponding object or the dictionary settings. Then I will run the top set again. Now it gives me the warning, and you will see here very important information. The cell set, solid cell set, has been created and has a size of 400, but overall the mesh didn't change, which means it only creates a collection of cells for the solid cell set, and a collection of cells of the solid set for the cell zone set. So it didn't change any mesh information. And the only thing, if you want to check, is now we have a new folder called constant. That means all the mesh information is stored in the polymesh, and there are two sets here. That's the only thing we did by using the top set dictionary setting. And the third step is actually to copy some schemes into the system, because in the following settings we need these two files into our has been created in our folder. So what we'll do, we'll just go to the tutorials and find the heat transfer as we said, and I just directly copy any of FV schemes or FV solutions from any folder, but and the CHT multi-region simple form. I copy this too, and remember we need to go to the system folder and paste here. So that's what you do. If you didn't do this step, you will find the further split mesh region cell zone override is cannot run. So that's what we need to do that next actually. So the split mesh regions is just a command based on our topology. So we have the cell zone especially here, which means that will do some actual operation to our cells, because it will physically separate them with different zones. So I can copy this, or you can type in if you want. So that's called split mesh regions, and the cell zone, which means we will split them by using the cell zone set here. We have only one cell zone set called solid, and I will override all the previous mesh. Now the mesh will be changed. So it is running properly. So the information here is it gives me 3 regions, so from region 1, from region 0 to region 1 and region 2. It gives me this information, and if I look into it, also creates interfaces between the different regions. So because I only have one region defined which called solid, and the other 2 regions is actually created with the default name called domain 0 and domain 2. The domain 0 we need to check its position, and domain 2 we need to check its position, because it should be one is air block, one is water block, and the solid is aluminum block. So that's what we do in the by split mesh regions. So that is 3 domains, 3 regions we created, and let's have a look at if it is. So we refresh the results, and we will see directly from here we have domain 0, so a lot of domain 0 here with different kind of mesh information, and we also have the domain 2, and we also have the solid, right? So I just unclick this intermesh and we'll apply again. So it looks like no difference, right? But if I change the legend into the VTK composite index, it will give me such information, because now the different color means different region settings for our current process. So we have a red region, which should be our solid. That's easy to figure out. So if I only use the solid, so that's solid region. And now what we're interested is which one is for our water and which one is for our air. So I have domain 1, domain 0. Now if I add this domain 0 to our display, you will see the domain 0 is below the aluminum block, which means domain 0 is our water block. And if I click the domain 2 internal mesh, and then it will be above the aluminum block. So that's how we define the regions. So domain 0 is a default name, but it is water block, and domain 2 is the air block. So that's how we did it. in the split mesh regions.